Now let's practice multiplying some rational expressions. Here's the first one. Please pause the video and see how you do. When we multiply rational expressions like this, we don't need a common denominator. We're just going to multiply the numerators together and the denominators together. And there's a couple of ways we can do this. We can multiply and then try to factor and reduce, or we can factor and reduce and then multiply. And I'm taking the second strategy. For one like this, it's not going to make a big difference, but as the numerators and denominators get more complicated, it will. So my numerator is going to be 2 times 7 times 3 times x squared, because I always like multiplying in prime factored form. My denominator is going to be 3 times 3 times 7 times x to the fifth. And now I look for common factors to reduce. I've got a couple of 7s. I've got a couple of factors of 3. And by the quotient rule, I can think of this as subtracting 5 minus 2 to get an x cubed down here. I just think to myself, I've got 5 factors of x. If I cross 2 of the 5 out, I've still got x cubed left. So I'm going to have 2 over 3x cubed. Here's another. By the same strategy, I'll have 5 times 5 times 2 times 2 times 3, and then times x to the fourth, and then my denominator will just be 3 times 5 times x cubed. I've got a couple of factors of 5 I can reduce, a couple factors of 3 I can reduce, and once I take 3 of the 4 factors of x to reduce these 3, I'll still have 1 factor of x left. So I'll have 20x. How about here? My numerator will be 5 times 2 times 3 times 2, and I'll bring along a factor of -1 for right here. And in the denominator, I'll have 2 times 2 times 3 times 5 times 3, and again another factor of -1. And in the numerator, I'll have a to the 10th, and in the denominator, I'll also have a to the 10th, because if bases are the same and you're multiplying, you can add the exponents. So here's my factored form. These two factors in -1 will go to +1, so I don't worry about those. I've got a couple factors of 5 I can reduce, and a couple of factors of 2 and 3, and one more factor of 2 that's common to both. And then, of course, a to the 10th divided by a to the 10th is just 1, as long as a isn't a 0. And so those will reduce, and I'm left with just 1 over 3, 1/3. Because this is in the denominator, so I need that factor of 1 up here. When you're reducing to factors of 1, not to zeros. Now we'll start working with a few more operators in the numerator and denominator. See how you do here. Well, I'm going to need to factor out a common factor of 2 here. And of course, this will be a 2 and a 3 and a 3. And so when I factor out that common factor of 2, I notice that I have a factor of x plus 1. And that can reduce, and I've also got a common factor of 3 here. So I'm going to reduce the factors of x plus 1, the factors of 3, and I'm left with 4. Here's another. This time I've got a couple of greatest common factors. I've got a factor of n here and a factor of 8 here, and so I'm going to factor those out. And then I notice I have a couple of factors of n that can reduce, and n plus 5s that can reduce, so I'll take those. And I'll be left with 8 times n plus 1 over 6. Make sure you keep your parentheses here, because that 8 has got to multiply both of these terms. And of course, I've got a common factor of 2 here, so this will be 4 and 3. And there's my final result. Try this one. I've got a factor of k in the numerator here and a GCF of 2 down here. So I'm going to factor those out. And then I notice I got a couple factors of k I can reduce and a couple factors of 2 I can reduce. So I'm going to take those. And that leaves me with 1 minus k over k minus 1. And you should recognize this as that form where we have opposites. And so that'll just simplify to negative 1. Try this one. In the denominator, I've got a greatest common factor of 3, so that'll come out. Up here, I've got a 3 and an m, and when our lead coefficient's negative, we take a negative with the GCF. So I'm going to factor a negative 3m out of both of these. And when I do that, I have to make sure this becomes subtraction, because if I multiply back, I need to get this addition idea. And so that's right here. This will give me this addition of 9m. So I took out my GCF here also, and my factors of m can go, my factors of 3 can go, and then I'm going to be left with a 3 minus m and an m minus 3, and those are opposites, and so they can go as long as I include a factor of negative 1, and then negative 1 times negative 3m, just 3m. Here's another. In the numerator here, I'm going to use guess and check. This is going to be x minus 5, x plus 2. Here my GCF is a 7. I've got a common factor of x minus 5. I've got a common factor of x plus 2. So I'm going to take those. That leaves me with 14 divided by 7, and that's just 2. Here's another. Here I have the difference of 2 squares. Here I'm going to use guess and check. I'm going to use guess and check here also. And here I have a GCF of 3. So this is going to be x minus 3x plus 3. This factors to x plus 5x minus 4. This factors to x minus 4x minus 4. And when I take the GCF here, I'll be left with an x plus 3. And now I can start taking my common factors. I've got an x plus 3, an x minus 4. But that looks like about it. So I'll just multiply my numerator together and my denominator together. And I'll get the quantity x minus 3 times x minus 4, and then 3 times x plus 5. Sometimes people want to multiply these out. Please don't, because if I look at this, I can tell right away there's no common factors left. But if you start multiplying it out, I'm going to worry about it and try to factor it back. So you might as well leave it like this. And here's our last one. Here I've got a GCF of m, and then I'll have a trinomial, so I'm going to try guess and check. Here I've got 4 terms, so I'm going to use grouping. So I'll take out my common factor of m in the numerator, and I'll start grouping in the denominator. And then this trinomial will go to 4m minus 1m plus 5. And down here, I'll continue grouping, and then I'll notice I still have the difference of 2 squares right here. And so that has to factor. And now everything looks factored, so I'll start taking common factors. I've got a common factor of m minus 1, and m plus 5, and 4m minus 1. And that leaves me with m over m plus 1. Well, that will conclude this video where we've had some practice multiplying rational expressions.